All right, in this video we're going to look at operations with matrices. So we're going to look at adding and subtracting and multiplying matrices. So we're going to be working with a few of these 6 matrices. So we can see A is a 3 by 3, and B and C are also a 3 by 3. D is a 2 by 3, E is a 3 by 2, and F is a 2 by 2. So for question number 1, we want to add matrix A with matrix B. So let's go ahead and work this out. So for matrix A is 3, 2, negative 5, 6, 1, and 7, and negative 2, 0, and 5. And we're going to add that to matrix B, which is 5, negative 6, 2, 4, 5, negative 4, 1, negative 1, and 0. So the way we add two matrices is we just add the entries that are in the same position. So 3 is first row, first column. 5 is first row, first column. So we're just going to add those to get the new first row, first column, which is 8. Then moving on to first row, second column of each. So I have 2 plus negative 6. That's going to give us negative 4. And then the last entry in this row, I have negative 5 and 2. So negative 5 plus 2 is negative 3. And then we'll continue with the other rows. So I have 6 plus 4 is 10. 1 plus 5 is 6. And 7 minus 4 is 3. And then on to the last row, negative 2 plus 1 is negative 1. 0 plus negative 1 is negative 1. And 5 plus 0 is 5. So this would be the sum of A plus B. We can do the same thing with matrix subtraction. We just subtract the entries that are common. So for A, again, I've got 3, 2, negative 5, 6, 1, 7, negative 2, 0, 5. And we're going to subtract matrix C, which is 4, 3, negative 5, negative 2, negative 1, 7, 4, 6, and 1. So I'm going to start with 3 minus 4. That's negative 1. And then 2 minus 3. Also negative 1. And then negative 5 minus negative 5. So that's negative 5 plus 5, which is going to be 0. So be careful with your signs. Moving on to the next row, 6 minus negative 2, which is 6 plus 2, which is 8. 1 minus negative 1, which is 1 plus 1, which is 0. And then 7 minus 7, which is also 0. Moving on to the last row, I've got negative 2 minus 4, so that's negative 6. Negative 2 minus 6. Negative 8, and negative 2 minus 1 is negative 3. All right, so that's A minus C. Moving on to the next one, we have 2B plus 3C. So this is just a scalar here, so I'm going to double B. I'm going to take matrix B and I'm going to double it. So 2B is going to be 10, negative 12, and 4. And then the next row, we'll double all the entries in that row. It's going to be 8, 10, and negative 8. And then the last row, 2, negative 2, and 0. So that's 2 times B. Then we have to do 3 times C. So we're going to triple all the entries there. So the first entry is 4, so 3 times 4 is 12, and then 9, and then negative 15. And then the next row, negative 2 times 3 is negative 6, negative 3, 7 times 3 is 21, and then the last row I have 12, 18, and 3. Now that I have 2b and 3c, I just have to add the entries in the same rows and columns. 10 plus 12 is 22. Negative 12 plus 9 is negative 3. 4 plus negative 15 is negative 11. 8 plus negative 6 is 2. Next entry would be 7. Negative 8 plus 21 is 13. And then the last row, 14, 16, and 3. So there would be 2b plus 3c. All right, moving on to number 4. So we know that A is a 3 by 3 matrix, and E is a 3 by 2 matrix. In order to do matrix addition or subtraction, the matrices have to be the same order. So this is not possible since matrices do not have the same order. All right, so let's take a look at number 5. Matrix D is a 2 by 3, and matrix E is a 3 by 2, so this is also not possible. So we're going to find out that we could actually multiply D and E, even though we can't add or subtract them. All right, so let's move on to matrix multiplication. All right, so matrix multiplication is defined if the column of the first matrix has the same dimensions as the row of the second matrix. So let's say our first matrix is an m times n matrix, and our second matrix is an n times p matrix. When we multiply those, we end up with an m times p, m by p matrix. All right, so for example, we can multiply a 3 by 3 by another 3 by 3. Since these two numbers in the middle match, we can multiply them, and then our answer would be another 3 by 3. Or we could multiply a 5 by 2 and a 2 by 6. Okay, since these middle numbers match, we can multiply this, and we would end up with result is a 5 by 6 matrix. All right, so let's see how this works. So this is tricky, and there's a lot of places to make mistakes, so be careful when you're doing these. So for A times B, I've got matrix A, which is 3, 2, negative 5, 6, 1, 7, and negative 2, 0, 5. And I'm going to multiply that by matrix B, which is 5, negative 6, and 2, 4, 5, negative 4, 1, negative 1, and 0. All right, so what I'm going to do is I'm going to take my first row and I'm going to multiply it by my first column to get the entry in the first row, first column of my new matrix. And the way I do this is I take each entry and I multiply it by another entry. So I'm going to do 3 times 5, and then I'm going to add. So now I take the next entry, which is a 2, and I take the next entry in that first column, and I'm going to multiply those. So 2 times 4 plus, and then the third entry in that first row is negative 5. So I'm going to do negative 5 times 1. So this is just the first entry, the first row, first column in my new matrix. All right, so now we're going to, to get the first row, second column, I'm going to take my first row and I'm going to multiply it by my second column and do the same multiplying and adding. So now I've got 3 times negative 6 plus 2 times 5 plus negative 5 times negative 1. So I took 3 times negative 6 plus 2 times 5 plus negative 5 times negative 1. And that's just going to be the second one. Alright, so we've got to continue with this. Now we'll take the first row and multiply it by the third column to get first row, third column of our new matrix. Kind of moving into problem 7 here. So we've got 3 times 2. Go to the next one, 2 times negative 4. So plus 2 times negative 4 plus negative 5 times 0. And that completes the first row of our new matrix. So just to take a step back here, A is a 3 by 3, and we're multiplying it by B, which is also a 3 by 3. So these match, and then our solution is going to be a 3 by 3 also. All right, so we have the first row column here. Now, we're going to take the second row and we're going to multiply it by the first column here. So I'm going to do 6 times 5, 1 times 5. Oops, sorry, that should be 6 times negative 6. 6 times negative 6 plus 1 times 5 plus 7 times negative 1. Alright, and then I'm going to multiply this second row by this second column. So 6 times negative 6 plus 1 times 5 plus 7 times negative 1. Alright, now we'll multiply by the last column. 6 times 2 plus 1 times negative 4 plus 7 times 0. Alright, and then moving on to the last row. Let's pick a different color here. Oop, it's not going to work. Alright, we'll just leave it as green there. Alright, so we're going to do the last row times the first column. So I have negative 2 times 5 plus 0 times 4 plus 5 times 1. Let's see, this up here should be a positive 1, so let's fix that. Sorry about that. Some of you probably found that. Alright, so now third row by second column. So I've got negative 2 times negative 6 plus 0 times 5 plus 5 times negative 1. Alright, and then third row, third column to get this last entry here. So I have negative 2 times 2 and 0 times negative 4 plus 5 times 0. All right, and then all I need to do is calculate what each of these entries is, and maybe you want to figure those out and double check with me, or double check that my answers are correct. So this first entry here is going to be 18. The second one here should be negative 3, and then this third one should be negative 2. Moving on to the second row, 41, negative 38, and 8, and then the last one, negative 5, 7, negative 4. All right, so that should be our final answer of A times B. So that's quite a long process there. So if you want to pause the video and go ahead and give number 7 a try, when you restart the video, the solution will be up there so you can check. And as always, make sure you ask if you have questions. So go ahead and pause now and give number 7 a try. We're just doing B times A instead of A times B. All right, so here's B times A. So you can check what you got for B times A, and if you have questions, make sure you ask. For number 8, for D, I have a 2 by 3, and I'm multiplying it by B, which is a 3 by 3. So again, we make sure that these match, and then our solution is going to be a 2 by 3. So if you want to work that out, I'll give you the solution here. You can pause it if you want. If we do that, we should get 21, negative 15, and 2, and negative 1, 2, and negative 2. Again, I recommend that you pause the video and work that out. Then for number 9, B is a 3 by 3, and D is a 2 by 3. So notice that these don't match anymore. So what that tells us is that we can not multiply these two matrices. Okay? All right, so that's number 9. Number 10, what do questions 8 and 9 suggest about how matrix multiplication differs from ordinary multiplication? So let's take a look at these two. So for 8, I could do D times B, but I couldn't do B times D. And actually, if we look at 6 and 7 also, I have A times B was this matrix, and B times A was this matrix, so you see that they're different. So 6 and 7 and 8 and 9 indicate that with matrices, the commutative property does not apply matrix multiplication. Okay, so for example, matrix A times matrix B does not necessarily equal matrix B times matrix A. All right, so that's it for this video. If you have questions, as always, make sure you get those answered. Actually, there's a couple of problems on the next page. If you want to just try those using reduced row echelon form on your calculator, for part A, you should get x is equal to 6 and y is equal to 3. And then for part B, you should get x is equal to 17 over 7, y is equal to 8 over 7, and z is equal to 30 over 7. Just convert your answer matrix to a fraction on your calculator to get these fractions. Again, if you have questions, make sure you ask, and we'll see you next time.